So here's the problem statement. You are given an array of integers stones where stone I is the weight of the ith stone. We are playing a game with the stones. On each turn we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have weights x and y with x less than equal to y. The result of this smash is if x equal y, then both stones are going to be destroyed, and if x not equal to y, the stone of weight x is destroyed. The stone of weight y has new weight, that is y minus x. So at the end of the game, there is at most one stone left. Return the smallest possible weight of the left stone. If there are no stones left, return 0. So example 1 is stones equal to 274181, output is 1. What is the explanation here? So when you will combine 7 and 8, right? Because we have to choose two heaviest stones, right? Two heaviest stones. 7 and 8 will be the same, so we are going to choose them. So what will happen? When you are going to combine them, you will be having the subtraction of these two values, that is 7 and 8. So we will be having 1. So 8 minus 7, we will be having 1, and we are going to have this in our array. So we will be having 2, 4, 1, 1, 1. This is our newly formed array. Now, two heaviest values that we do have is they are 2 and 4. So if you will combine them, this is how our new array looks like, 2, 1, 1, 1. Now again the two heaviest values we will be having is 2 and 1, and if you will combine them, we will be having 1, 1, 1. Right? Now the two heaviest values, you can see all the values are okay, they are equal, so we will be having 1, 1 itself. It means value of x is equal to value of y, right? So both the stones are going to be destroyed. Okay, and this time just one stone is left, that is of weight 1. So if there's just one stone left, what we don't have to proceed further, that's it, which is done. Okay, so 1 will be the output. For this one, there's only one stone, so we will be simply returning that. Okay, so first thing that can come to your mind for solving this problem is that how we can do. Like first, sort our array. So we will be having this array on sorting, right? Now what you can do is you can simply choose, because at the end the last two values will be the heaviest one that we have to choose. So we can choose them. We will be choosing 7 and 8, right? And we have to simply append the subtraction. We have to simply add the subtraction of these two values. So 1, 1, 2, 4 and 1. Right? Now you can see the array is not sorted. So we again what we'll be doing is we'll be sorting this. We'll be sorting. Again, you will be choosing the two heaviest values. So you will be having 1, 1, 1. 4 minus 2, you will be having 2. Right? Again, we will be repeating ourselves. 2 minus 1, you will be having 1. Okay. So for now, this is a sorted sequence, but there can be possibility that the sequence is not sorted. For example, in that case, right? So we have to sort this again and again. Whenever you are doing this operation, subtraction and all, you have to sort the array again, so that we can make sure elements are in sorted format, and the last two values will be the heaviest one, right? So this is how you can proceed. Like you must be getting the flow that first you have to sort the array, then you have to choose the last two values, right? Get the subtraction, right? On smashing the values that you are getting, add this newly created value in your array, and again sort this, right? To make sure that the array is sorted, and we can just last two values should be the heaviest one, right? But if you are thinking of this approach, so you can see again and again we are doing the sorting part, right? So this is obviously increasing the time complexity. So this is not a better approach to go, right? So what further improvement could be done? So you can see we need here heaviest values, right? We need the heaviest value, largest value we can say. So can we use some data structure here? Yes, we can. So we'll be using what? We'll be using, yes, you guess it right, we'll be using max heap here. Okay, so max heap will do what it will do. It will make the things easy for us. It will take care of the largest value that we need. Let's discuss here only. So this is the array elements that we are having, right? So what we'll be doing, first of all, we'll be inserting all these array elements in the max. Then we'll be popping out the elements from the max heap. So the highest value is 8, and the next highest value that you'll be getting is 7. So simply just subtract these two values because they are not equal, and add them to the max heap. Right, so what will be the values now in the max heap? 2, 4, 1, 1, 1. Again, we'll be asking for we'll be popping the value, so you will be obviously getting the maximum value 4. Then the next value that is maximum, that is 2. So you'll be getting 4 minus 2, 2. So we'll be adding this 2 to our maxi. Now the values will be this 2, 1, 1. Okay, so this is how not maxi is represented, but just to make the things easy for you, I'm showing this in linear fashion. Now 2 minus 1 you'll be getting, because these are the two highest values, right? First you'll be getting 2, then 1. 1, 1, 1. Then again we'll be asking for what? We'll be asking the values, popping out the values. First value, then second value. So as if these values are equal, we don't have to add the, they'll be destroying, these stones will be destroying each other, so we don't have to add this to the heap, right? So 1 minus 1, you'll be getting 0. Now just one element is remaining in the heap, and that's it. We have to stop right there at this particular condition. Okay, so this is how we can use maxi for solving this problem. Talking about the time complexity, so time complexity as well as the space complexity. So time complexity is going to be n log n, and the space complexity will be n, because you are inserting n elements to the maxi first, right? So n log n, and even you must be knowing that for in the case of maxi, we have to do the heapy piping again and again when you are inserting, when you are removing. So that takes log n time, right? And we are having n elements here. Okay, so I hope that you must have understood the approach that we're going to use here. So let's have a look on the code part. So this is the code for the approach that we discussed just now, right? We are having the priority queue, right? That is being working as a maxi for now. By default in Java, it is, right? It is in min heap format, right? You must be knowing that, right? So first of all, what we are doing is we are adding the array elements to our priority queue. Then we have to continue, we have to do the processing again and again for the priority queue till the time there is more than one element. So that's why we are having a while loop, that while the size of priority queue is greater than 1, continue in the loop. So we are taking the top element, then another top element, right? Because we need two heaviest stones. So if these values that we got P1 and P2, if they are not equal, then what we are doing is we are simply adding the subtraction of these two values to our priority queue. Okay, and this is how it continues, and if they are equal, then we don't have to do anything. Okay. And at the last, we are simply checking that if the size is equal 0, it means there is no element or there is no stone remaining, then we have to simply return 0. Otherwise we have to return the value that is remaining, that is there in the priority queue, right? So I hope that you must have understood the approach and the code part as well. Thank you for watching. I have provided a code in the description, so in case you want to have a look. So thank you so much for watching, everyone. Bye bye.